Thank you for the kind introduction. My name is Sandra Höltervennhoff from Leibniz University, Hannover, and today I'm going to present you our research, which is an interview study concerning the unsafe feature of the programming language Rust. And before I start, I want to thank my amazing co-authors, as the work would not be possible without them. So, why should one use the Rust programming language at all? Most level languages like C or C++ are powerful and fast, but also impose the burden of secure programming on the developer, as security mistakes can easily be made. And to help with secure programming, the language Rust was created. It is designed to still be fast and performant, but also to provide concurrency and memory safety. But in order to achieve this, the programmer must comply with certain security guarantees, as the code is otherwise rejected by the compiler. And actually, these restrictions can be too strong for some use cases. So in these use cases, one has to resort to so-called unsafe Rust, as there are 5 actions that can only be performed in unsafe Rust. And among other things, this includes something like accessing raw memory by pointer dereferencing, or calling other unsafe functions. And here it has to be said that all functions from other programming languages are considered unsafe, as the Rust compiler obviously cannot check them. So what is the problem with unsafe code? As I've just said, the compiler is not able to check and verify these new unsafe actions. So memory safety guarantees are not enforced. And essentially that means that for unsafe actions, Rust's famous safety guarantees are fading away. So the developers again have to do it for themselves, and issues like memory mismanagement or undefined behavior might arise more easily, as they do in other languages. And for all of you who have not seen Rust code before, or unsafe Rust code, I brought a little example on pointer dereferencing to access raw memory. And while for time reason I won't elaborate on it in detail, in the main functions we can see an unsafe block that starts with the unsafe keywords and lives in the curly brackets. As unsafe code is such a critical part of Rust, there exist several research papers. But mostly they are focusing on the as-is state of unsafe code. For example, they analyze unsafe code fragments that they got from crates.io, which is the Rust standard package registry, and are looking in the code if they find any security issues, or they try to isolate unsafe Rust code from safe Rust code. However, there's only little research on the human aspect and the handling of unsafe code, on how developers write, review, and test their unsafe code fragments. And this is where our research comes in. We did an interview study with Rust developers to investigate how they use and approach unsafe code, and if they do that securely. During our interview, we investigated the 4 research questions, which are how they decide for using unsafe Rust and how they implement it. Secondly, how they assess unsafe Rust features, limitations, and security risks. Thirdly, how they review and test their unsafe code. And last but not least, if they've experienced any security incidents in their projects because they have used unsafe Rust before. And before I come to the results, I will first dive into our interview methodology really quick. We conducted our interviews online so that we could get a diverse sample of Rust developers, and we targeted a time frame of approximately 1 hour for each interview. I think on average our interviews lasted for 57 minutes. And on the right side of the slide, you can see the typical procedure of the interviews, which were divided into 7 thematic blocks. And we tried to explore experience and comprehension of the developers, ask about the testing and tooling practices for unsafe code, ask for project-specific security policies and guidelines regarding unsafe code, for their code reviewing strategies, and lastly, for the incidents and threat models that happened because of unsafe Rust. All in all, we interviewed 26 Rust developers that had all worked with unsafe code before. So now let me present a selection of our results. First, and luckily, we found that most of our participants tried to avoid unsafe code and only used it if really necessary. For example, if they wanted to use Rust in connection with other languages and also not in critical code. As one of our participants stated, I wouldn't want my unsafe code to run my pacemaker. However, some participants also explained that they would use unsafe Rust if the performance was noticeably better. Regarding their writing process, participants generally reported a thoughtful process. So they tried to encapsulate the unsafe blocks in safe-to-use interfaces and wrote good documentations, which contains also safety comments stating why and when an unsafe block is safe to use and which invariants have to be upheld. Moreover, we found that several of our participants utilize other Rust projects, so-called crates, that already encapsulate the unsafe use case, so that they don't have to write unsafe code themselves. However, what we also found is that participants often pick those crates by reputation only, like their popularity, or at most meta-verified them without doing a proper code review, which could lead to insecure dependencies. And in a few times, unsafe code was used without diligent care. So for example, we had a few participants that knew that the unsafe code could lead to undefined behavior. And two reasons for that was that the code was perceived as less important or security critical, or that the project just had too many lines of unsafe code. Regarding the assessment of unsafe code, we found that unsafe was often perceived as a marker of sorts or a beacon for the developer, so an area where critical bugs might occur and which they could monitor more closely. And in this context, they regularly mentioned that they could focus on those areas better as they are more contained. However, many of our participants also mentioned that unsafe code could be scary or hard to write. And reasons were that it could be challenging to write unsafe code correctly and to consider all soundness issues or side effects. Moreover, some of our participants had misconceptions. So they thought that inside unsafe Rust, somehow all compiler checked would be turned off. And this is not true, as the compiler cannot check the 5 new unsafe actions, but everything else is working like a normal safe code. Regarding policies, we found that only very few participants had security policies in their project, like mandatory security comments or API policies regarding the usage of unsafe Rust. And with project-level recommendations being rare, most developers trusted in their common sense or the common sense of their peers and decided for themselves when unsafe code should be used or not. Like one participant stated, in a project, when the topic of unsafe code comes up, it's because it's clear that something should be solved with unsafe code. However, some participants also named constraints. For example, that the code has to pass a code review, or that in the end, the lead or senior has the final say if the code is staying or not. Participants also tried to test their unsafe code more rigorously, for example, by writing more tests. But also some participants stated to test unsafe code less often than safe code. And that was not always voluntarily. A prominent reason was like the border to other programming languages and interaction with low-level hardware, which make testing rather complex or even impossible. And also, a few participants perceived the security tools like code linter as too complex in their usage or setup, and in consequence, just didn't use them. Finally, and luckily, when we asked for incidents, our participants did not yet experience any severe incidents caused by unsafe code. However, some participants gave examples for security-relevant bugs that were only found post-release. Mostly, however, these bugs were described as minor or non-exploitable. Then again, some participants reported unsafe bugs to be very subtle. And critically, several of our participants that reported undefined behavior or bugs in the code did not necessarily connect them with vulnerabilities at all, and this even included bugs that led to a local denial of service. Now that I've presented a selection of our results, I will come to a quick roundup and then state our recommendations. So it can be concluded that unsafe code is mostly used securely, and I think that's a very promising finding, but not always. So the Rust community successfully communicates the risk around unsafe code and discouraged developers from using unsafe Rust if feasible. Nevertheless, we found that participants became inattentive or annoyed if unsafe code was frequently used. And this was especially relevant as there are no project-specific guidelines or policies on when to write unsafe code. And we found divergent opinion in detail, for example, what really should go inside an unsafe code block and whether unsafe code is needed or not. Moreover, some of our interviews indicated that experience might not always be sufficient to handle unsafe code, as some of our participants had the misconceptions or still did not really feel confident in the unsafe code that they wrote. We therefore recommend to improve the communication of unsafe Rust even further, as the comprehension is really important in writing securely. While there is already a lot of information regarding unsafe Rust in the internet, a big factor for the future is the packaging of information so that developers are less likely to shy away from reading it and have it bundled in one place and easier to find. And as developers often only have little time, this information could also be accompanied by quick-to-read roundups that may also include actionable guidelines for deciding for and writing unsafe code that can be adapted by individual projects. Secondly, as the configuration of some security tools for Rust was reported to be cumbersome by some of our participants, we recommend to deploy simplified onboarding assistance like configuration wizards to make it as easy as possible to use those tools, especially as previous work found that security is often only a secondary concern for developers. And lastly, support should not only be offered with tool setup, but also with a selection of dependencies. We recommend assisting developers in choosing the right crates, for example, by providing easy-to-read metrics via crates.io. And examples of such metrics could be the presence or the absence of unsafe code in a crate, or code reviews done by trusted entities. And I think already a good example is the tool CargoVet that checks if third-party Rust dependencies have been audited by a trusted entity. However, as such external tools were seldom mentioned during our interviews, we really suggest to integrate such metrics as seamlessly as possible into crates.io to increase the adoption by the developers. With our recommendations given, I hope that I could spark your interest for reading the whole paper, and I thank you for your attention. I'm now open to take questions.
Thank you, Sandra.